Okay, this should be a pretty short video. It's pretty straightforward. In this video, I'm going to provide some feedback for Module 1. I did not receive any emails or any direct questions about Module 1, so I assume everybody knows why they got the grade they did and understands all the concepts from the module. But just in case, I'm going to cover a few things here. So first thing I'm going to need to do is share my screen with you. So bear with me while I get that ready. Okay, the first thing I want to talk about is the discussion. If we look at the prompt here, the question you are asking is, should we continue to use coal to produce electricity? Now, even though that was the question, that wasn't really what we were after, right? If you look at the bottom here, and I'll go through the stuff in the middle, but if you look at the bottom, this is what we're after. You do not necessarily need to agree with your answer or your responses. You just need to make an argument based on a specific ethical point of view. So the point here is not to actually defend a stand for or against coal. The point is to be able to explain from which point of view your stance takes. We are not truly debating the advantages and disadvantages of coal, because we will do that later in the semester when you actually learn about coal production, or excuse me, energy production by using coal and the other methods of energy production. So the purpose of this discussion is to demonstrate that you understand the different ethical points of view. So that's an important thing to keep in mind here, that this is really what we're after. The point here is for you as the student to demonstrate to me that you understand these different ethical points of view. And let's look at that. So you're going to answer the question, should we continue to use coal to produce electricity? Or really, a better question would be, is it the right thing to do to continue to use coal to produce electricity, right? Because when we talk about virtue ethics or consequence-based ethics or utilitarianism or duty-based ethics, right, all of those, it's a question of what is the right thing to do? Should you do this or not? And that's what you're looking at. And again, this is what you're trying to demonstrate. So really quickly, obviously virtue ethics, to put it succinctly, not to go deep into any of these, but virtue ethics would be, what are you motivated by? So one could argue that unless your intention was to harm the environment, which coal has been shown to do, unless that was your intention, then by virtue ethics, you did nothing wrong. One of your classmates, or perhaps you, if you're watching this, one person did make the argument that if your intention was to make money and then disregard the harm possibly done to the environment or to the employees, the coal miners and such, then therefore by that rationale that using coal would be the wrong thing to do, which was an interesting take. I've never seen that as a response before, because generally speaking, again, by virtue ethics, the usual argument is that unless you intended to do harm, then it's the right thing to do. And sort of the opposite of that would be consequence-based ethics, right? Consequence-based ethics doesn't matter what your intention was, it's what happened. So in this case, I very often see the argument where someone says, well, you may not have intended, your intention, your motivation for mining coal and burning coal to produce electricity was not the negative side effects, right? Your intention was the positive economical side effects, consequences. The positive consequences as far as producing electricity, right? So as long, that would be virtue ethics. Now with consequence-based ethics, again, that's more looking at what happened due to your decision. Let's talk about an example that has nothing to do with biology. Let's say there was somebody casing a neighborhood, right? And he wanted to break into houses and steal things. And let's say he picked out a house with an elderly woman living in it, and he's been watching it for a week, and he's figured out her schedule, and he knows that if he goes in there at 9 p.m. on a Thursday, that she's definitely going to be asleep, and that would be a great time to rob her house, right? So he goes 9 p.m. on a Thursday with the intention of robbing a house, right? So right away, we know by virtue ethics, this person is in the wrong, right? without a doubt, because the intention there was to rob someone's house. So this person breaks in, he finds the elderly woman, down on the floor. She's unconscious. Something's wrong with her. So what does he do? He uses the phone to dial 911, says that, an ambulance is needed, and then he leaves. And by that, and in that example, someone might be able to argue that by consequence-based ethics, that person was in the right. Right? It doesn't matter what he intended to do. What did he end up doing? He didn't rob her, and he ended up saving her life. Right? Someone could make that argument. Now, going back to the actual question at hand, which is about using coal to produce electricity, some of the common arguments I saw from you were, as far as consequence-based ethics were concerned, was you looked at the consequences, right? So you were weighing the good consequences versus the bad consequences, and I love that perspective. And you could take that either way. So if you're pro coal in this discussion, you could say, look, here's the positive consequences. We are employing people. We're providing cheap energy. We're providing energy that is not reliant on other countries, right? Domestic energy. So all those things. And and this is where the opinion comes in your opinion, those positive things outweigh the negative things, right? The harm to the environment, the harm to the coal miners, things like that. And then, of course, the opposite is true, is if you took the position that the coal was bad based on consequence-based ethics, you would look at the same thing, right? The same outcomes, but in your opinion, those negative outcomes outweighed the positive outcomes. And that's an important thing to think about, not just for this module, but for the entire course. A lot of this, you're going to be presented with facts, right? You're going to look at the pros and cons of different things, the costs and the benefits. But then it's up to you to form an opinion, right? It's always an opinion. Do the pros outweigh the cons? Do the costs outweigh the benefits? Those are the things that you have to decide. And that's exactly what you did in this discussion. Moving forward, utilitarianism, as you demonstrated in your responses, or your posts, utilitarianism is basically a subcategory of consequence-based ethics. So we're still looking at the outcomes, except it gets a little bit more specific with utilitarianism, because then we're not just saying, all right, do all the pros outweigh all the cons? Then you're specifically looking at people, right? Are you bringing, I think the book even used the word joy, and as one of the words that it used, right? Are you bringing joy? Are you bringing happiness to the most amount of people with your decision? So that's utilitarianism. Duty-based ethics, the way your book describes it, it's also pretty straightforward. According to your book, anyway, duty-based ethics is basically, is it illegal or not, right? Is it illegal to do what you're doing? If it's not illegal, then what you're doing is right. And if it is illegal, what you're doing is wrong. And of course, that is a very interesting statement, because when you think about it, a lot of horrible things have been done that were legal, and vice versa. So not many people chose duty-based ethics. And I wish the person who did choose that was here to talk to me and get in on this conversation, because they made a pretty interesting case for duty-based ethics. But again, the point here, the overall point of this discussion, is that you needed to, in your initial post, demonstrate that you understood one of those ethical points of view. So how do you go about doing that? Well, if you scroll down here, at the very least, you needed to define it. You could say, I believe that we should use coal to produce electricity because, and I am using a virtue ethics point of view, which is, right, and then you go on to define it. And then you would go on, after you've written your definition, to relate it to your post, right? All the different things that you listed in your post, you would relate it to your ethical point of view, the definition of your ethical point of view. And most people did that. Most people didn't have a problem with it. Where people usually miss points is right here, these last two bullet points. You need to include a reference, and you need to properly incorporate the reference. This is a university rule. I didn't make this up. So when you're doing discussions, you should include a reference. That's something that should be across the board for all online courses where you have a discussion. But I happen to really agree with that. If you are making a statement, if you are arguing a position, you should include a reference. I tend to do that myself, and I don't mean online professionally, but if I'm talking to somebody or writing with somebody online, even though I do teach biology, if I'm going to make a statement, about COVID, for example, and talking about the vaccine, maybe if I'm going to say something about how mRNA works, yes, I teach it. And yes, in my opinion, that should be good enough for me to explain how mRNA works. But if I were to write something about how mRNA works, I would look it up and I would find a great source to back me up. So including a reference is it's important, both because it's required by the university and it's a good habit to be into. So anyway, not properly incorporating the reference. What I mean by that is you can't just write your post and then at the end of the post put a link at the bottom, right? You should somewhere in your post say something like, well, according to coalmining.com, West Virginia employed X number of coal miners last year, right? So you should say how you use your source, because I've seen it in past semesters where people would just put any old link. They would just Google anything to do with that week's discussion and put a link to satisfy the requirement. But that will not get you all the points that you need for discussions in this course. So make sure you use a reference and make sure you incorporate it properly. And that's pretty much it. Everything else is pretty straightforward. I don't remember any points being lost for anything else. I will point this out again. I said this during the last meeting, but as far as errors are concerned, generally speaking, if you have errors, singular or plural, you only lose a point. But there are some occasions where some people clearly are just writing as little as they can, not even putting forth an effort. And if they have a really, really, really short post, then I might take away 1 point per error, right? Because, if you're gonna do the bare minimum, then I'm going to do the maximum as far as grading is concerned. And I wish somebody was online. Let me check back to my other screen. Nope, nobody's online. All right. So I would ask if you have any questions, but because no one is online, I will move, I will move forward. So that is the discussion. Let's move to the lab, the first lab of the semester. Let me go back here. I'm going to switch my screen so you can see the lab. Okay, I am now sharing my screen. You should be able to see Lab 1, the Goldfish Lab. Before we get started, I'm going to state the obvious. This lab really has nothing to do with goldfish, right? Who cares about goldfish? Has nothing to do with environmental biology. The point of this lab is really to familiarize you with the scientific method, to give you a little bit of experience setting up an experiment and running an experiment, collecting data, and analyzing the data, right? And the reason it was so simple is because this is the first lab. So I'm not trying to make it hard. I just want to give you experience, with the scientific process. So let's move forward. One thing I do want to point out, because I commonly see this mistake in many semesters, including this one, is the relationship between a hypothesis and a prediction. Now, actually, let me back up and let's talk about the scientific process in general. If you were to look up the scientific process, it's not one set process. Excuse me. It's not like there's a scientific congress and someone says, all right, well, this is the scientific process and all the scientists have to agree. It's not like that. So I challenge you, actually, go Google it. Google the scientific process and you'll get many different results. Now, they're all very similar, but they're not exact. So with that in mind, keep in mind that I am teaching out of the book. So I'm teaching you the scientific method as your textbook writes it. So the first step in the scientific process is an observation, right? You see something. In this case, I'm going to use the example that is in the lab itself. Let's say you observe the fact that your dog urinates in the same spot of the yard every time you let it out to urinate. And the observation that you see is that the grass happens to be really nice at that spot where the dog urinates, right? That's your observation. And that observation could lead to a question. Obviously, the question there in this situation, in this situation would be, is dog urine good for grass, right? And what always comes after a question? Well, theoretically, always comes after a question would be the answer. In this case, the answer is what we call a hypothesis. It's a tentative answer, right? We're saying, I hate to use the word guess, but you probably grew up learning that, right? It's an educated guess. And in a way it is. You were saying, you were answering the question, but the thing is, your answer, your hypothesis, has to be something that is testable, right? So I'll use a different example. If someone were to say, why does this particular area of, I don't know, India flood every year, right? That would be the question. You observe that it floods every year on the news. Your question is why? What is it about that area that makes it flood every year? So a hypothesis could be, well, there's something about the weather patterns that make it happen at the same time every year. You could test that, right? You can go back and look at the weather patterns for years, right? Centuries. You could look back and find that out. That's testable. What you couldn't say is, well, the people of India have bad luck, right? And that might be who knows? I'm not telling you what's right or wrong. That might be the right answer. Maybe they have bad luck. I don't know. But the point is, that's not testable, right? You cannot test if they have bad luck or not. So that would not be a hypothesis. Yes, it is a tentative answer, but it's not testable, so it's not a hypothesis. Anyway, going back to my example, again, you observe that your dog urinates in the same spot. The grass is great right there. You wonder if urine is good for grass, and your hypothesis is yes, urine is good for grass. That's your hypothesis. And that brings us to a prediction. And as far as I'm concerned, and as far as your book is concerned, a prediction is basically an if-then statement, right? And it's written in such a way that you are basically describing how you're going to test your hypothesis. And in real science, when you have a hypothesis, you don't just do one experiment. Well, usually you don't just do one experiment and say, okay, I'm done. Usually if you test your hypothesis, and then it turns, the evidence supports your hypothesis in one experiment, then you devise another experiment and test it again, and you keep going and you keep going. The point is, you're trying to basically falsify your hypothesis. So that brings us back to predictions. So if my hypothesis is that dog urine is indeed good for grass, then I could come up with a number of predictions, but I only wrote 3. Prediction 1, if I make my dog urinate, excuse me. Of course, this would happen in the middle of a video. Okay, if I make my dog urinate in a new spot, right, so not the spot that it's always been urinating in, then the grass in that area will start to grow faster, right? So that's prediction 1. If he goes in a new spot, then the new area is going to have better grass. All right, so let's say I do that, and sure enough, wow, yeah, the results really do support my hypothesis. Well, it's back to the drawing board. Let's come up with another way to test your hypothesis. So prediction 2, if my dog stops urinating in the normal areas that have great grass growth, then the grass will stop growing so quickly, in that particular area, right? So where it used to be nice, where the dog used to urinate, if they're no longer doing it, then the grass won't be as nice. That, again, would support your hypothesis. Then you go to prediction 3 and maybe perform a controlled experiment. If I grow 30 plants in pots, giving 10 plants pure water, another 10 plants a mixture of half water and half urine, another set of 10 plants pure urine, then the plants receiving pure water, will have grown the least in 6 months, followed by the plants receiving half water, half urine, followed by the plants receiving pure urine, which will have grown the most. So you can see, again, these are 3 different predictions based off of one hypothesis. And of course, of these predictions, this third one is the most scientific. And that's a whole different discussion, talking about how to set up an experiment and reduce the variables. But we can talk about that some other time. Let's move forward. So that was just an example. What you did was you were working with goldfish, right? So the observation that I gave you is that different species of fish thrive in different temperature ranges of water, right? So, excuse me, you might imagine that, a fish that thrives in the coral reefs off of the coast of Florida might not do so well off of living under an iceberg, for example, right? And vice versa. So we know that different species of fish require different temperatures. Based on that, one might ask themselves, will the temperature of the water affect the breath rate of fish? Now, in my opinion, this is actually kind of a silly question, because you might define breath as literally breathing in air and breathing out air, and that's not what fish do. But I didn't come up with this website that we use, so breath it is. After the question, again, comes the hypothesis, and this is where your first question is. You actually need to choose a hypothesis, multiple choice here. How do you think the temperature will affect the breath rate? As the temperature increases, will the breath rate also increase? Or will it decrease, or will it stay the same, right? That is your hypothesis. Next comes your prediction, which again, as far as we're concerned in this semester, it's basically an if-then statement. If we put goldfish in bowls and increase the temperature and count the number of breaths they take, then we will find the respiration will increase, decrease, or stay the same. So again, talking about this relationship between hypothesis and prediction, the prediction is basically, in a sense, rewriting the hypothesis, except you're using words in such a way that you are describing how you will test the hypothesis, right? So in this case, you're putting the fish in bowls and you are counting the number of breaths. Another way you could do it is, a different prediction would be, if we put goldfish in bowls, increase the temperature, and monitor the oxygen concentration in the water, then we will find the oxygen concentration will decrease, right? Or the carbon dioxide concentration will increase, right? Because you use oxygen when you're respiring and you produce carbon dioxide. So that would be a different prediction you can make based off of that hypothesis. But of course, because you are constrained to what the website uses, so obviously counting the breaths was the only thing you could do in this experiment. So moving forward, this is the really easy part. You basically went to this website, you followed the directions. I'm not going to waste your time going through that, hashing that out, because you've already done it. I'm trying to think of some of the mistakes I've seen and the mistakes I normally see throughout the semesters. This one, all right, this is something to discuss. So we didn't just use one fish, right? It's not like we just put your fish in warm water and then put it in cooler water and then put it in even cooler water and so on and so forth, right? We didn't just do your fish. There was also other fish, right? One group used a different fish, another group used another fish, so on and so forth. You use multiple fish. And this is important in any real experiment, because think about the fact, what if we just did use your one fish? And of course, assuming this is not an experiment done on a website virtually, but if you were doing a real experiment, what if we just used one fish and there was something wrong with that one fish? Then your data, while it might be correct for that one fish, might not represent goldfish in general. So it's a good idea to have more than one subject. The more the merrier statistically, and that's a whole different discussion that we'll talk about later too. But this is where I saw many mistakes. So I would say about a quarter of you, your numbers, right, your number of breaths per 30 seconds was much higher, usually twice as high as the other 4 fish. No one lost points for that, but it's a good learning moment. The thing here is, this is something you should look at. The fact that your numbers are so much different than everybody else's might indicate that there's something wrong with your fish, or it might indicate that there's something wrong with the way you performed your experiment. And most likely that is the case. Most likely you just counted wrong, because if you remember the way the website works, they provide you with a little stopwatch, and it's not digital. It goes in a full circle. And the odd thing about that is, as the minute, I made the mistake right there, as the hand goes all the way around a full revolution, which we recognize as a minute, for the website, a full revolution is actually 30 seconds. So that explains some of the mistakes I saw. Anyway, again, no one lost points for that, but that should have been a red flag to you. And more importantly, forget about this lab. Think about the fact that one day you are going to be a college-educated citizen. This is the kind of thing that you should recognize in real life. So if someone hands you a study and says, look, this is why vaccinations are good, and then someone else gives you a study and says, look, this is why vaccinations are bad, you should look at the data and look for things, right? Don't just read the abstract where the abstract says, yep, vaccinations are good, or no, vaccinations are bad. Look into it. You're not necessarily doing your own research. Someone's already done the research, but look at their results. Look for those kind of red flags. Especially imagine if someone gave you something and said, look at this study, look at the results of this study, and then you were to look at the data and they only had one subject, right? That would be a red flag. Anyway, yeah, so that was one of the more common mistakes, which again, no one lost points for. The other mistake I saw was this right here. So you had your 5 fishes and then we needed an average. And I don't have time, and this is not a math class, so I'll go ahead and be honest with you. I did not calculate each one of your average to see if you were wrong. All I did was what I call lookology. For example, if the highest number you had right here was 31, and say the lowest number you had right here was 27, and you said your average was, I don't know, 25. Hey, there's a red flag. Obviously, you messed up because your average falls outside the range of the rest of your data. So that's what I was looking for when I graded. And for the most part, everybody seemed to get it correct. And again, that's the kind of things you should look for when someone presents you with a study. Look at the data. Look for these red flags. Now, granted, if someone's presenting you with peer-reviewed data, you can assume someone's already done that. Quite a few people have already done what I've described, looking for red flags and looking at the data, but you never know. It doesn't hurt to look. So yeah, that's it for the table. I don't think anyone else missed anything other than those 2 things. Let's move forward. The graph. The graph was also pretty straightforward. This is the first graph you've done this semester. Some people did lose some points. Mostly because you didn't provide a title and you didn't label your axes. That was the most common mistake. So make sure you always have a title. You always label your axes. I like to say the easiest way to remember this is if someone finds your graph, looks at your graph outside of this class, right? You just show them the graph. You don't show them the whole lab. It should make sense to them, right? There should be enough information on your graph where they understand what they're looking at. So for example, if your title for your graph was lab number 1, and then on your y-axis, right, the vertical axis, you just have a bunch of numbers, which we know represents the number of breaths, but they don't. And then the bottom just has, categories, 10 or below, 11 to 17, 18 to 20 run, right? And it doesn't say temperature, and it doesn't say Celsius. Then that would mean nothing, right? That graph would make no sense to the person reading it. So make sure your graphs make sense to people out of context, basically, right? You don't need the supporting study, or in this case, the supporting lab, for it to make sense. Moving forward, let's see, some people missed a point because they swapped the y and the x-axis. That's not a real big deal. Overall, that would be okay, right? You're representing the data. That's the point of a graph, is to show the story of your data, so to speak. So in a real life situation, you probably would have the decision what's going to go on the y-axis versus the x-axis. But a small part of getting a college education, or any education really, is in fact to get you prepared for a career, right? That is one of the things, trying to get you ready for the job market. And one of the things you're going to need to do in the job market, almost definitely, depending on what you do, is you're going to need to follow instructions and follow them carefully. So you did lose a point if you did that. Here's another more important thing that I did see as a mistake. On your x-axis, you should have 5 data categories, 1 for each temperature range, right? So try to picture it. I wish I could draw on this. But your x-axis, right, that's the horizontal one at the bottom, where the bars come up from. It shouldn't be fish 1 versus fish 2 versus fish 3 versus fish 4 versus fish 5, right? It should be this temperature range versus this temperature range versus this temperature range, so on and so forth, because that's the question, right, that we're answering in this experiment. Does the temperature affect the breath rate, right? The question doesn't say, does the age of the fish affect the breath rate? In which case, it might be beneficial to have fish 1 has a bar, fish 2 has its own bar, fish 3 has its own bar, so on and so forth, and maybe each fish was a different age. But that wasn't the situation, right? We're not comparing the different fish. We are comparing the different temperature ranges. As a matter of fact, that's why we take the average, right? We're not looking at fish 3, we're not looking at fish 1, we're looking at all of them as a group for each temperature range. So some people did make that mistake. You definitely lost a point for that. And again, that is a little bit more important than swapping your axes, because you need to recognize when you're trying to present your data, which is what you're doing in a graph, you need to know what you're doing, right? You're not looking at fish 1 versus fish 5. We're looking at this temperature versus that temperature. Yep, so that's it for that. Then moving forward, this part is very straightforward. The next question asks you to enter the web address, right? So again, your experiment was online, it was all virtual. When you were done with the experiment, you knew you were done, the website told you so. At that point, you were supposed to go to the browser, copy that link and paste it here. And that's just proof to me that you actually did the lab and didn't copy off of somebody else or just guess at any of this. Question 15, describe how the fish's respiration rate changed. So basically, did it go up with the temperature, or did it go down with the temperature, or did it stay the same? So you're supposed to describe what happened, describe the data. Yes, you've already put the data here, but in this part, you're supposed to put it into words. And that is very common in science. You represent your data in different ways. Numerically up here, in a graph right here, and then right here, you put it into words. Very simple. I don't think anybody missed that one. Question 16, propose an explanation of why this happened. Turns out that yes, in this experiment, respiration rate does increase with the temperature, but the question is why. There were many answers. Again, this lab is not really about goldfish, so it doesn't matter what you put as long as you answer something. Question 17, what else could have affected the rate other than temperature, right? So yeah, on the last one, you guessed why temperature would cause that to happen. And then this question that asks you what else. No one lost points for this, but I really wanted you to think about the fact, for example, somebody put something like the age of the fish. And if you were looking at just one fish, that wouldn't make, actually, that would be a whole different discussion. I don't want to get into it on this video. I'm already going long anyway. So if you have questions about that, no one missed it, but if you have questions about it, contact me and we can discuss it. Question 18, and I've already discussed this earlier in this video, but let's bring it up very quickly again. Was the average, that's this number right here, was the average similar to your data, right? So even though you've already done this, again, I'm trying to get you to reflect back on your experiment and reflect on your data. Again, another chance for you to look at it and see those red flags. And yes, none of you lost points if you were wrong, but hopefully you would have seen that and said, well, yeah, my data does not look like the average. Maybe something is wrong. Maybe I should try the experiment again. And hopefully you did, but this is the first lab and this is a 100 level course, so that is not required. Anyway, I don't think anybody missed that question, but the purpose of that question, again, is to have you reflect back on your data, look back at your table and say, hey, was something wrong there? Question 19, I've already mentioned this in this video, but why do we take an average? There's a lot of reasons. You can look it up as you did and find many different answers as you did and include your source, as most of you did. Some of you lost points for not including your source. But what I was getting at here with the average is, again, thinking about the fact that your data may have been very much different than the other data. So one of the advantages to taking an average is that kind of helps equal things out, right? Sure, your numbers may have been a lot higher, but you had 4 other fish that were more accurately representing what was going on, and the average helps take care of that. Yeah, so again, I don't think anyone missed that other than the people who didn't include a source. Question 20, was your hypothesis at the beginning of the lab correct or incorrect? Again, you're going to see a lot of this with these labs. This is the way science is. It's repetitive. Obviously, I know whether your hypothesis was correct or not because I can look up here, see what you chose for your hypothesis, And then I can look right here and see what the results were. But that's not the point. In science, very often, especially if you're writing a paper, at the beginning of the paper, you write your hypothesis. This is what I hypothesize. This is how I tested it. These were the results. And then again, you go back and you would say, turns out my hypothesis was correct, or my hypothesis was incorrect. I will say this will be a little bit more important later, and nobody made this mistake because I think the way this question is worded. But I try to avoid the word prove. And I've already seen from module 2, people are already starting to use that word. The better statement would be, I did the experiment and it supported my hypothesis, right? It doesn't really prove anything. Obviously, the more experiments you do and the more data you have, right? So if you had more than 5 fish, the better it is at supporting your hypothesis. And you might get closer to proving it, but I don't like to use the word prove. And that in itself would be its own video, so I'll leave it at that. Number 21. In this experiment, you counted the breaths of goldfish to measure the respiration rate, right? It was very unrealistic. You could see the little mouth moving with bubbles coming out, and that's not what goldfish really do, but the website was trying to keep it simple for you. So I was trying to get you to think of something a little bit more realistic, right? What other ways could you measure respiration rate, right? What other ways, other than watching the little mouth move and the bubbles come out, could you measure the respiration rate? Because they don't actually breathe the way humans breathe, right? So the way the website is set up is not very realistic. And then I wanted on to tell you this information is not provided, right? So I just wanted to make sure you didn't think to yourself, uh-oh, I must have missed something in the lab, and go back and go through the whole website, right? The information is not provided. You just needed to think about it. So again, instead of looking at the fish and counting how many times its mouth opened and shut and counted the little bubbles, instead of doing that, what could you measure? Some of you, I like these answers. You said you could look at the gill movements, and that's good, right? You could. Another thing you can do, and I give you a hint here, and I've already said it earlier in this lab, is the hint is that animals use oxygen when they respire, and they produce carbon dioxide when they respire, right? So you could, if you had a way of doing so, and there are ways to do that, you could measure the oxygen concentration and the carbon dioxide concentration. And obviously, the quicker the oxygen concentration goes down, or that the carbon dioxide concentration goes up, the more respiration is happening. But again, this lab isn't really about goldfish. It's really about the scientific process and getting you to think about experiments. And that is another good thing, because again, yes, you tested your hypothesis in one way, but you need to think about what other ways can you test a hypothesis, because in real life, generally speaking, you can't just test it once. And if it supports your hypothesis, then you're done, right? Then you need to go back to the drawing board, come up with another prediction, and test it again. Moving forward, we're almost done here. Thanks for hanging with me. Question 22. Forget the experiment that you just completed. This is the hard part. I'm trying to get you to purge your brain, and many people weren't able to do this. Maybe because I was not clear enough, but no one lost points for this. But forget what you know about how temperature affects the respiration, and only focus on this new question. Do goldfish breathe faster as light increases? Right hypothesis. I think a lot of people overthought this. They didn't have to. Basically, you just need to think back to the original hypothesis, except with light. Forget temperature. Your hypothesis should be how do you think light affects the breath rate, right? As the light increases, the respiration rate will increase, decrease, or stay the same, right? That's all you needed. And then, again, you're just supposed to write a prediction based on that hypothesis for question 23. And if you're kind of doing it the same way, I give you the little experiment set up. So it should say something like, if I expose one fish to complete darkness, one fish to one light bulb, if I expose let's just say a fish instead of one fish, or fish in general. If I expose fish to darkness, and then one light bulb, and then 2 light bulbs, and then 3 light bulbs, and then 4 light bulbs, then I will see that the respiration rate will increase or decrease or stay the same, whatever your hypothesis would be. But again, I'm trying to get you to think about this relationship between a prediction and a hypothesis. So yeah, some people miss points for that, and now you know why, right? I didn't tell you why when I marked it wrong because I wanted to provide you with the opportunity to fix your mistake. And I told you to get in touch with me if you wanted to know why you got it wrong, and now you do, right? So it's a relationship between the hypothesis and the prediction. And to keep things easy for this course, your predictions always need to be if-then statements. And then finally, oddly enough, people miss this. Question 24 and 25. Sign this, right? Put your name, and then save this file as a PDF before you upload it. I know that sounds ridiculous, but again, going back to what I was saying earlier, one day you're going to have a job, most likely. And most likely in that job, you're going to have to follow instructions, specific instructions. And depending on your job, those specific instructions might, be very important, and you might cost you your life if you mess it up, or you might cost somebody, a couple bucks at a restaurant or something. I don't know. But the point is, you definitely do need to get used to following instructions. So yes, you would lose a point if you do not save it as a PDF. But on a more practical note, there's something wrong with Moodle or Microsoft or something. And very often when you save something as a non-PDF format before you upload it, then something happens when you upload it and I lose stuff. So if you upload a Microsoft Word document, for example, and then I go to grade it, it might be missing a whole page, and then you'll just be missing all those questions, right? You'll lose all those points simply because you didn't save it as a PDF. Whew. So that's it for the feedback as far as the discussion is concerned and as far as the lab is concerned. And this is a really good time to tell me the part that hopefully this is a really good time for me to tell you, hopefully the part that you'll really enjoy, which is that because this is the first module, I will allow you to go back and fix your mistakes for full credit. So for the lab, this is very straightforward, right? You have the lab, you have the file on your computer. Just go back in and fix the mistakes you make. Delete the old file that's on Moodle, right? And then upload your new file. That's all you have to do. And when I get around to grading it, you will receive full credit. Potentially, that's assuming you actually correctly fix your mistakes. And the same can be said for the discussion for this module, because again, it's the first module. If you didn't get maximum points and you've tried the extra credit and you still didn't hit your full 25, then you can still go back and write more responses. And I will give you full credit for the responses. And you can do that until you hit 25. I will say this, though, for the initial post that was due on Wednesday, and this is a good time to remind you of that, the initial post has to be in by Wednesday. Otherwise, well, for this week, you'll get half credit, right? So if you still haven't done it, go ahead and do it. You'll get half credit for it, but go ahead and do it. And then moving forward, from now on, if you miss that deadline, that Wednesday deadline, you just get 0 points. I don't do late assignments. You have to get it done on time. And I mentioned this in the last video, the Welcome to Environmental Biology video, and I want to mention it again. I understand I was a student before too, and at the time, I was a non-traditional student, so I was also working at home, a family and all that, so I was busy, and there was very often times when I turned in an assignment or even worked on the assignment at the last minute. I know I shouldn't have, but sometimes I couldn't help it. And I'm sure some of you are in the same situation. A lot of you are procrastinating and waiting until the last minute, not because you're lazy, just because that's what life requires of you. But nonetheless, if you miss something because life forced you to wait, doesn't matter. If you miss the deadline, you miss the deadline, and you'll miss the points. I know that doesn't seem fair, but it is fair. You just have to accept the consequences. I did it as a student, and so will you. So that's it as far as the discussion and the lab are concerned. Now, as far as the quiz is concerned, again, because this is the first module, if you haven't done it, or if you want to go back and do it again, go for it. I opened it back up yesterday, and it will stay open. So you can keep going until you get the grade you want, again, because this is the first module. Moving forward for modules 2 through 8, you will not be able to go back and take quizzes. So I guess that's it. Now let's jump into very quickly, some hints for Module 2. So now we're looking forward. Let me pull this up and share it with you. Scroll down here. Excuse me. Where are we at here? There we go. Scroll down here to Module 2, and I'll give you some quick hints on the discussion. Now, if you look, I've already made a video that you can watch about this. So this is going to be a very quick discussion, because if you want a more in-depth discussion and more hints, then watch the video. That is in-depth. Just really quickly, I just want to point one thing out. The common mistakes I see is that, here we're talking about the fact that the human population is approaching carrying capacity. So then the question is, what can we do? Can we reduce human population growth? And or should we increase the carrying capacity? And for the sake of this discussion, you have to choose one of those two things, and then produce an idea, offer an idea of how we can reduce human population growth or how we can increase the carrying capacity. That part's the easy part. Where I see people mess up is you need to list an advantage, just one advantage and just one disadvantage. The reason I only want one is because I really don't want to get you to truly defend your position. The purpose here is to demonstrate that you understand the concepts of human population growth and carrying capacity and the relationship between the two. So the reason you only need to list one advantage and one disadvantage is because if you list them all, then your classmates have nothing left to say when they respond, right? So you want to leave something for your classmates. So please don't mess that up. Only list one advantage and one disadvantage. Another thing I see that people make a mistake on, let's scroll down here. Not demonstrating that you understand the concept of carrying capacity. You need to at least define both terms. Define carrying capacity and define population growth. And if you really want to be impressive, you can really quickly discuss how they're related to each other, right? But at the very least, you should define it. And then after you've defined it, relate that to your post. So if your idea for reducing human population growth is to get rid of WIC, I don't know, so people no longer who can't, then maybe you might think that, all right, if people can't afford children, they won't have them, right? Maybe that's your idea. Well, as you're defending your idea, you should somehow relate the definition of carrying capacity and population growth to your idea. And that's it. Again, if you watch this video that I show right here, there's much more to say about this. Oh yeah, one more thing too. Sorry, I keep going on and on. But the last thing you really should know, and I see this all the time, is first of all, again, you were given the choice here whether we're talking about increasing the carrying capacity or reducing population growth. So very often I see people get upset about this whole idea of reducing human population growth. Say, well, first of all, I'm not saying that's what you have to do. You can choose the other one. Second of all, and this is the big mistake I see here too, is we are talking about reducing human population growth. The key word there is growth, meaning we're not talking about reducing the human population, right? You don't need to go murder people or commit genocide. You could reduce the human population growth by, well, I give this away by, like your book says, if you provide better education and more economic opportunities for women in, third world countries, for example, when they have their own choices and they are their own person and they're not basically just living to do what their husbands say, and their husbands want more children, then that has been shown to reduce the human population growth. And again, that's not forcing anybody to do it. That is giving somebody a choice. That's providing more opportunity and letting them make their own decisions. So please don't make that mistake. We're not talking about reducing the human population. We're talking about reducing the human population growth. And more importantly, when we discuss that, it does not necessarily mean you are forcing it. The example I see often is the China example, where they mandated that you could only have 2 children per couple, right? That doesn't have to be the case. You can influence population without mandating something, right? You can provide incentives. You can take away other incentives. But anyway, that's it for that. I really wish somebody else was online so I could take questions, but no one is. So I'm going to end this video. Before I do end the video, I'll say this. If you've watched this video and you want to get the extra credit, send me an email. Say you watched the video. Tell me where you would like the extra credit point applied. It'll be 2 points for watching the video. And I'm going to ask you what a keyword is. And it's going to be two things. It's going to be a word and then a number. So the word is fan, and then the number will be adding up your name. So for example, if your name is Jim Bob, right? Jim is 3 letters. Bob is 3 letters. So 3 plus 3 is 6. So if Jim Bob were to write me an email, he would say the keyword is fan 6. And that's it. And you might be wondering why I'm doing that. Short answer is I'm trying to prevent people from just saying they saw the video without actually watching the video. Of course, there is a way around it, but at least I want to make it a little bit harder for those who are trying to cheat. So that's it. I hope you have a great week. If after watching this video you have any questions, please let me know. Visit me during office hours. I'm here to help.